So is this where we need to put arrows in and that kind of thing?
Yep.
So I'm guessing the pull force will be like an arrow going right.
Alright.
Will there be a weight force going downwards or something like that?
Let's see. Yeah.
Or I don't know if gravity just generally hold the item down. Um,
Well, it's got a weight force pulling it down.
is there like air resistance as well from the other side? Or
We model it as having no air resistance. However, it is a rough horizontal plane, and so we would say it has a friction resistance.
okay,
There's one more. Do you know what it is?
uplift, upthrust, something like
Normal reaction because of the weight.
that. Okay.
So because that's pressing on the ground, you have a equal and opposite. Resultant R is the normal reaction. Reaction R for I wrote N. Maybe I should write R. Yeah, because N is like newtons. Okay, Grant. I think we have the idea. F for friction. Okay, any idea about this?
Um, so are we now just doing the same thing we just did?
Um. Uh. Yeah. If you want, we could skip A. What would be part B?
It says describe the
Okay. So, all right. So we have this thing. Um. It just seems like it's very similar. And what would be the motion of the particle?
Um, I'm not entirely sure what they mean by like the motion of the particle.
Will it move left? Will it move right?
I'm assuming move right
Why is that?
because we for the previous answer we assumed it was moving right.
Uh, for this one,
Oh, will it be that it's moving upwards actually?
yeah. With how much force?
20 newtons upwards.
Yeah,
Yeah.
that's it. So the previous one, we just didn't know what the values were. Yeah. Oh, there we go. So it's like that overall would be 20 up. So it's like a simplified version. Excuse me. Okay, so it's like simplify the diagram. Okay, that's now I get it. We could do more of those. So we will. Let's just do a quick one. This was 10.1. Okay. What is question 8? Hang on. Yeah, this one would be better to start with. Alright, it's kind of the same. Alright, so for each of these, it is stationary. Hang on, let me just bring it in. So that's that, that's that, that's that. Alright. For each of these, it is stationary. And so what is the value of P and Q in each of these?
Sorry, what stationary? Sorry.
The particle is stationary. So the particle isn't moving.
Okay.
And so what is the value of P and Q on each one?
Will P, the first one, be 15N?
Yep. And second one?
Will P be 16N, Q will be 24N?
Yep. Last one.
So I think that P will be 20N, and then Q will be 45N.
Yeah, so P must be 20 and Q must be 25. Yep, that's it. Newtons is just like centimeters, you know, it's just a unit of measurement. They get more complicated. We better do this one. Yeah, so how about these? Oops.
So here is the resultant force 0 for A.
The resultant is just like overall, doesn't have to be up or down. So let's say you were to simplify the diagram, what would it be?
Would it be like the particle is moving 50 newtons to the left?
15 newtons, which way?
Left. Oh, right, sorry, right.
Yeah. And so, yeah. And B?
And here is it just the particle is moving downwards 25 newtons.
Yep. So that's 25 down. Fine. Let me just make sure. So that one is like that. Yeah. Yeah. We could do stuff. Okay. That looks fine to me. 1 second. Yes. Okay, great. Okay. Force diagrams is good. Forces as vectors. 1 sec, sorry. This one. Put that there.
Probably a tick.
Great. Okay, how about this? Yep, let's give this a go.
So all of these forces are like 4 different forces on one force diagram.
So that's essentially it. Yeah. So it would be like 2i and 3j. So that's 2 to the right, 3 up. So maybe it looks like that. Minus 3i plus 2j. So that's maybe like that. And then you have this one. I'm just going to take a guess. It's like that. And you have to say, what is A, what is B, given that this thing is held in equilibrium.
And
you can break it down to just its I and J. So any idea? If it's in equilibrium, do you know what that means?
it's the same.
So basically they'll add up to 0. So when you add up all the forces, oh, I missed a force in there, did I? J plus AI plus B. So when you add them all up, you get 0. And you can collect all the i's, do it that way. So 2i minus, 2i plus 4i minus 3i plus ai, that will give you 0i. So you use that to figure out what a is.
And I think yeah. And so now I'll just put them into my calculator, don't I?
Yep.
Is it basically just the same as doing like 2 plus 4 minus 3 plus x equals 0?
Yeah.
Or even I think so. It'll just be a equals 0. Minus 3.
Okay. So a is minus 3. How about b?
And so for b, I just need to now put all the j's equals plus bj equals 0.
Yep. And you can even do it without the j.
Yeah. Minus 4.
Great. And so minus 3i minus 4j. Great. So if they're in equilibrium, they add up to 0. It's not moving. Let's see this one. Hang on. Yeah, looks good. Okay, let's try this one.
Okay, so is that like us doing 2 plus 3 minus 1 equals to p, no, plus p equals to 0, or
That would be if it's in equilibrium. It isn't. So it is actually moving. So it's like 2 plus 3 minus 1. So what is that?
4.
So, okay. And then so that's the J. And then the other one? Sorry, that's the I. And the J?
3.
Okay. And so it is, its resultant force overall is 4I plus 3J as a vector. Yeah, that is, part B.
So I think for the magnitude, I just need to do square root of 4 squared plus 3 squared,
Well done.
which will be 5.
So that's 5 newtons overall. They want the bearing. So this,
So the angle.
yep.
So is the bearing just the angle in between 4 and 3?
Let's see. So the angle that this thing is going at, 5 newtons. You got an angle there.
And so here I can just use SOHCAHTOA, can't I?
Yep.
And so if I do something like sine theta is equals to 3 over 4. Oh no, 3 over 4, sorry.
True. Let's use the values that we originally had, because maybe we made a mistake with our 5.
So should we do tan theta is equals to 3 over 4?
Yeah.
And then octan theta is equals to 3 over 4. Yeah.
Mm-hmm.
I'll spend my calculator now.
Mm-hmm.
Okay, so I got 36.9.
36.9 degrees. And strangely, or maybe not, I don't know, they asked for a bearing. And so what would be the bearing? Any idea about that?
Is that just like me doing 90?
Yep.
Oh wait, minus 36.9.
Yep.
And I got 53.1.
53.1. And I believe with bearings you have to say 0, 153.
Okay.
153 degrees. And overall, describe the motion of the particle.
So if I 4I plus 3J, is it going upwards by 5 newtons or something?
Yep, it's going, it's on a bearing of 153 degrees with a force of 5 newtons.
Okay.
Force 5 newtons, yep. So you have a bunch of forces acting on it. Do I have a nice, not really. I'll just use this one. So you have like a bunch of forces acting on it, and then so overall it's going in some direction. It's like these, you know, you have like lots of forces acting on it, but overall it's going in a certain direction. This is going right, this is going down. Our one is going kind of diagonally, 153 degrees, angle of, force of 5. Okay, any questions about that?
No.
It's all right. Okay, let's try this one.
Okay, so are we now gonna do 4a minus 2b minus 12 equals 0?
Mm-hmm.
And then we're gonna do a minus 8b plus 12 equals 0.
Mm-hmm.
And then we'll enter our simultaneous equation calculator.
And so the calculator takes in the form of equals a number. So the two variables are on the left and then the numbers on the right.
Okay.
And so you'd have to bring these two over.
So do I need to do then 4a minus 2b equals to 12 and a minus 8b equals minus 12?
Yeah, that's exactly how the calculator takes it in.
And I got that a is 4 and b is 2.
Great. Part B.
So do I now need to sub in my answer for a and b into f1 and f2?
Yep.
And then add them together?
Yep.
And so that'll be so like 16i plus 4j,
Mm-hmm.
and the second one it will be minus 4i minus 16j.
Yep.
And now I just need to add those together.
Mm-hmm.
And so that will be 16 minus 12i, or even just 12i.
Yeah.
And minus 12j.
What are you putting into calculator for that one?
Is it 4 and then minus 8 times 2?
Yes, sorry. Minus 8 times 2. So that is minus 12, yep.
And now I need to do the square root of 12 squared plus minus 12 squared.
Yep.
And that is 12 root 2.
Great. Let me see. Let's just get it to 3 sig figure. So just in case.
And so that would be 17.0.
Okay. And in newtons, yeah, and C.
So do I now need to draw two lines with 12 going across and then minus 12 going down, and then the magnitude of 17?
Yeah.
And So the unit vector j, that's where like 12 is, I think. When it says line of action of I,
I is across, J is down.
so is that the angle I'm trying to work out?
Which angle?
The one you just drew of 90 degrees?
No. It's between the red line and the vector J. Which one is the J?
Oh, is it the one at the very like bottom right corner?
Yeah, so I think it's isosceles, and so it kind of doesn't matter, but just for future, yeah.
Okay. And so now, should I do like tan theta equals to 12 over 12?
Mm-hmm. Hang on. Is it 12 over minus 12?
I guess so.
Alright, what's that?
Um, what brings my calculator? Sorry, so I got 135 degrees.
135 degrees. Seems kind of big.
Yeah.
Put in just arctan 1.
They gave me multiple answers, but that's the only answer within 0 and 180 degrees.
You love to overcomplicate stuff. Arctan. So I'll try 1. I get 45. Minus 1. Minus 45. Yeah, just use arctan. So I believe it has to be 45 degrees.
Yes.
And yeah, I suppose if it's isosceles and that's 90, then these two have to be 45. Yep. But we used a good 135. It was right. Were you using minus 1?
I just did tan x equals to 12 over minus 12.
Oh, I know why. Because they found, so if you have that one, they found like the on the other side of it. That's not clear. They should have said obtuse angle, I think. Or I suppose, yeah, I think they should have said obtuse angle. But okay, great. Any questions about that one?
No.
Okay. Find the angle between F2 and I. I think you get the idea. The resultant is R, given that R is parallel. Let me see this one. Oh no, yeah. Okay, how about A for this one?
Okay. So for F1, that's like 3 across, 2 down. I'm not entirely sure what F2 looks like yet.
So you want the angle between F2 and I. So let's just say F2 is like that. That's A, that's 2A.
And so the magnitude is the square root of 2a squared, or just
Doesn't matter.
okay.
Angle. between the magnitude and the resultant and I.
So that'll be just one opposite R.
No. I is this one. Going right.
Oh,
like,
sorry. Is the one on the left?
Yeah.
And so am I now trying to form an equation to try and find theta? Or
Yep.
so would that be like tan 2a over a equals tan theta is equals to 2a over a.
Yeah. And it's always tan of the j over the I, opposite over adjacent.
And that will turn to tan theta equals to to 2, sorry.
Mm-hmm.
And so arctan would be equals to 63.4 degrees.
That's great. And that's okay. The resultant of F1 and F2 is R. Okay, how do we do this?
When something's parallel, is that like 39 plus 10j? Would something parallel to that be like 26i plus 20j?
So that's an example. In general, you could just say like something times 13i plus 10j.
Okay.
Yeah, it could be 2, could be 3, could be -1, could be a half.
So would I have to say something like 3i minus 2j plus ai plus 2aj equals to k 39 plus 10j?
Yeah. Oops.
And so now, should I break it down and separate the i's and the j's?
Mm-hmm.
So should I do something like 3i?
And we can leave out the I.
Yeah, just 3 plus a equals to 13k.
Yeah.
And then for the j, we do -2 plus 2a equals to 10k.
Yeah.
And then if we want to put into our calculator, should we then switch it around and do like -13k plus a equals to -3, and then -10k plus 2a equals to 2?
Yeah, that'll work. A little less work would be bringing just the A over. Moving one thing instead of 2, but it'll get you the same answer.
And so I got that k is a half and a is 7/2.
So it's like 3.5, 0.5. And you're sure that that's K and A in that order? I'm not sure.
Yeah.
Okay. A is 3.5. Yep. And do you see K anywhere? That'd have to be a half. Yeah, I'm sure it's correct. And that one's 63.4. Great. Yeah, so if it's parallel, you can write it as times K and then use that, go from there. And then this one, tan theta, even though it was in terms of A, the A is cancelled. And so watch out for that. All right, unless you have any questions, I'm moving on. This one is very similar. Is it worth doing, or you think you'd be okay?
I think I'll be okay.
Right. Let's see. So this one is similar enough. It's now written in vector notation. You call it column notation. Is it worth doing?
It might be okay as well, I think.
Yeah, it's like if you have to do simultaneous equations, it's like 2a plus b minus 11. Like they're kind of, instead of I and j, it works like that. This one is an equilibrium. Find a and b. The thing is removed, the magnitude and the angle. So it's the same questions, different notation. Hey, great, 10.2. Okay, forces and acceleration. Weight is mass times gravity. Fair enough. Okay, how about this one?
Okay, so is that just going to be 1.5 times, or even 6 divided by 1.5? So the acceleration is 4.
So 6 over 1.5 equals 4 meters per second squared. Yep. Okay. This here shows the acceleration. And so let's try these.
Will X be 2?
I think it might be, yeah.
And will Y be 2? 2G?
Y is definitely 2g, yeah. Okay.
And so here, will X be 82?
Maybe I'm wrong about this. Hang on.
Yeah, even I'm getting, I think I might be just guessing a little bit here.
Hang on. So F equals ma. So this one over here, it's like x times acceleration has to give you 4. And the acceleration was 2. Yeah. So that one's x is 2. Y for, yeah, that's just in a different direction. Wait. Yeah, I think that has to be just 2g. Yeah, sorry, because they put in g. Yeah. This one over here. So which one were you doing first? X?
Yeah.
So F equals ma. The way you do the force overall is like x and minus 80. So x minus 80, that's the left and right force, equals mass. What is mass?
4.
And acceleration?
2.
So I'm going to say minus 2, because we said that that's minus 80, and that's plus x. And so you'd solve that one.
And so that would give me X minus 8. So well, that should be X is minus 10. Even probably 10. 10.
Let me think. You would add the 80 across.
Yeah, so that would be 72.
So that's 72. That looks all right. So if that was 72 and that was 80, then it would accelerate to the left. Yeah. Overall, hang on. Overall, that would be 8 going that way. Who knows? Let's see. And then how about Y?
And so here, does it need to have, would it just be like 4g plus 20?
Yeah. Yeah, equals y. That's it, literally. Because it's not accelerating up and down. 4g plus 20. So they got it as 59.2. Same thing. And then the other is 72. Great. I think we're all right there. Yeah, F equals ma. Total force, total mass, total acceleration. Let me see. That's example 6. Let me just see. Total mass. So we did this one. Okay. To up and down, I think is okay. They really emphasize up and down. They're really emphasizing up and down. Yeah. But the... Oh, okay. No, hold on. Oh, that's weird. I'll look at it later. I think you're good. Okay, how about this one?
Will it be 16 divided by 5?
Yep.
And so that would be 3.2 meters per second squared.
Okay. So I need a... Okay, part B.
This is probably one of the first. No, it shows like seconds. Do I need to like sort of solve that equation or something? Or
Yep.
so am I saying like t is for a is 3.2, s is s, and is there some sort of way that I need to work out that the so u is 0?
Yep. And I need to put in stuff. S is equal to ut plus a half at squared, I believe.
And so So now I just need to do s is equals to 0 to, or just more, s is equals to half times 3.2 times 4 squared.
Yep.
And I got 128 over 5.
Let's say as a decimal.
25.6.
Yeah, 25.6 meters. Because that's just as exact as the fraction, and it kind of tells us something like it's between 25 and 26, you know. Okay, C.
So is that going to be something like, is that like the square root of 20 squared plus 4 squared?
No. Between the table. This is the table down here. What's the downward force?
Weight.
Yep. What's the weight?
Of the 5 kilos.
That's the mass.
20 newtons.
Weight is 5g. Mass times force of gravity. What they are asking you to find is the normal reaction, which is that one. So normal reaction.
So I'm getting a bit confused, I think.
The body isn't moving up or down. It's moving to the right, but it isn't moving up or down. And so...
5G.
Yep, 5G. That's how it works.
Yeah.
And 5G is 49 newtons, because it's 5 times 9.8. Great. Acceleration is 3.2, and then suva 25.6. Grand. Any questions about that?
No.
Okay. Let's try this one. Oh, these are going to be brutal.
Okay, so yeah, I think here for A, I can. Should I use a Suva equation?
No.
Should I use force equals mass times acceleration?
I believe so.
So will the mass be 800 kilos?
Yeah. Maybe you're right. Maybe it is suva. let's try Suva.
So, okay, I think it's U is 0, A is A, S is 5, V is 3.
3, yep. Yeah, it helps us here.
And so that will become, yeah, I need to sub that in now.
AS. Okay, try that one.
I got that. Acceleration is 0.9.
Okay. B. Any idea about this one?
Okay, if the lift is moving vertically downwards. Is tension a force?
Yep.
So we're now just doing 0.9 times 800.
Let me think about this. So, all right, what do you get?
I would get...
No. Let me think. So it's basically F equals ma.
Yeah.
F equals ma. The mass. The mass is 800. The acceleration is 0.9. But the force, if it's going down, then the tension is going up. So you've got weight and tension like that. And so the force would be weight minus tension. And so what is the weight?
The weight is 800. Oh no, the weight's in newtons, isn't it?
Yeah. What was weight for this one?
49 newtons.
Simpler than that. So the mass is 5, so the weight is 5g. 5g is the same as 49 newtons. 5g newtons, 49 newtons. It would be like 100 pi is 314 whatever.
So will our weight here be 800g?
Yeah. 800g minus t. So we want that tension because they're going down, but the thing has to stop them from like free falling or something. Yeah, and so solve for t. Tension is like friction. It's like acting against the motion of direction.
So is it just 800 times 9.8?
Yep. 800 times, no, well, yes. 800 times 9.8 minus x equals 800 times 0.9.
Yeah. I got 7,120.
So tension is 7,120 newtons. Okay. And then part C. The tension in the cable if it's moving vertically upwards.
Do I now make 0.9 negative? Or?
I don't think we have to. See, it's now moving upwards. And so tension would have to be bigger than weight. For it to move upwards, to accelerate upwards with a speed of 0.9 meters per second squared.
I'm sorry?
So for the first one, it was like weight minus tension.
Yeah.
I believe now it would be tension minus weight.
And so that would just be Okay. So that would be 7,120.
Different tension. Tension 2.
So would it be T minus 800 equals to 800 times 0.9?
Yeah, something's missing from the left side.
T squared.
No.
Oh, would it be TG?
800G.
800G, sorry, yeah.
Wait, yeah.
$8,560.
60 newtons. So on the way up, so the acceleration, so they're saying if it's accelerating with a speed of 0.9, if it's going down, then weight would have to be bigger than tension. So it'd be like weight minus tension. If it's going with 0 point speed up, speed of 0.9 up, then it would be tension minus weight. Let's see, 7,120, 8,560. Great. And so, yeah, friction is always, it's a bit like friction. If friction is going to the left, then a thing must be moving to the right. If friction is going to the right, then the thing must be moving to the left because it acts against it. Same with this. If this whole lift is moving down, then tension would be moving the opposite way. If the lift is going up, then the tension would be in the weight. It'd be, yeah. All right. Any questions there?
No.
All right. Let's see. So this is the same idea, exact same, except it's left and right. Let's just take a look. Yeah, so you can see there it's just left and right instead of up and down. My guess is that's a bit easier. Maybe we should move this one back. This one is very similar, left and right. This is a bit trickier because they take away a force like we were doing. But it's the same idea. Okay, forces on acceleration. What do you give yourself?
Probably 2.
That's all right. How was that for you, Andrey?
Yeah, that was good, thank you.
And so, stats next time?
Yes, please, yeah.
Any questions in general?
No, I don't think so.
How's school going, by the way?
So, it's alright. Yeah, it's just online school. It's sort of what you expect online school to be, but yeah.
I have no idea. All
Yeah.
right. All right. Well done, Andrey. You did great. I look forward to chatting again next time.
Yeah, cheers. Thanks.
Take care. Goodbye.